A manufacturer knows that their items have a normally distributed lifespan with a mean of 14.7 years and a standard deviation of 3.7 years. The 10% of items with the shortest lifespan will last less than how many years? Well, the first thing that I notice in this problem is that I'm told that I have a normally distributed set of data. So that right there is helping me identify that the way I'm going to solve this problem eventually is using the normal distribution in some way. Now, the question that's being asked is right here, the 10% of items with the shortest lifespan will last less than how many years? So it's asking for a number of years in the answer, not for a probability. So since I'm not calculating a probability, then I'm not using the normal CDF function, but instead the inverse norm function. Before I get too far, however, it's probably a good idea to sketch a distribution and put the pertinent information on there. So for instance, we have a normally distributed set of data that has an overall mean of 14.7 years and a standard deviation of 3.7 years. So this axis here is something in years, not in z-scores or probabilities, but years. So the mean number of years is 14.7. What I want to know is the 10% of items with the shortest lifespan, so the smallest number of years, will last less than how many years? So the shortest 10%. So 10% of my region's data. I don't know exactly where that is, but I'm going to shade what I feel is approximately 10%. And it's important to understand that what I'm shading is the percentage or the area under the curve. And what I'm looking for is a number of years, because that's my clue that I need to use the inverse norm function rather than normal CDF. So the inverse norm function, it accepts up to 3 inputs. And those inputs are an area to the left, the mean of a distribution, and the standard deviation of a distribution. Now, the mean and the standard deviation I've already been provided. That was given as 14.7 and 3.7. So it's the area to the left of the score that I'm most interested in that I'm going to come up with. So the area to the left of this value that I'm looking for. So I change this and make it a value x. So I'm looking for x. So x equals this. Then the area to the left of x. The amount of shaded area to the left of x is 0.1, 10%. So what I will do now is get my calculator, and I will go under the distributions menu, down to inverse norm. The area to the left is 0.1. The mean of the distribution is 14.7. And the standard deviation is 3.7. Now I just simply input these values separated by commas. Press enter, and I come up with a value of 9.958. And I follow any rounding rules that were given by the problem. Generally, the suggested rounding is to round to the same accuracy as the mean and standard deviation. So for instance here, those are accurate to the first decimal. So I would round this to the first decimal, which would make it 10.0. But just follow any rounding rules that are provided in the problem. Now, when you were using the calculator, some of you may have noticed that when you use the inverse norm function, that you were given a menu. And that happens on the later model TI-84 calculators. And to show you what that looks like, you end up with this when you start the inverse norm function rather than the ability to just type in the inputs. And in this particular case, it works in the exact same way. It's just the calculator's trying to help you remember what inputs go into inverse norm rather than you having to memorize the order and that sort of thing. So area is 0.1, that's the area to the left of the score that we're interested in. The mean of our distribution is 14.7, and the standard deviation is 3.7. When you enter that and hit paste, then what the calculator does is just feeds that information in the correct order, separated by commas, right into inverse norm to get you the correct answer. So it's just a bit of a helping feature.